Hello and welcome. What we're going to do right now is go through how to identify reaction types. This will be the first part in a two-part series. In this video, we'll analyze synthesis, decomposition, and combustion reactions. Please note that in this case, we're going to be using the term synthesis, but it's also known as combination reactions in some books and resources. So let's take a look at each one individually first. So the first type of reaction, one of the most simple forms of reactions, is synthesis reactions. And what I have here for you is a general form where A plus B yields AB. So two simple things will form one more complex item. All right. Now A and B could be compounds. So just recognize that that is possible. But A and B are any random element or compound combining to form a more complex compound. AB will always be a compound, clearly. The second type of reaction that we're going to investigate here is decomposition reactions, and as the name suggests, something is going to decompose. It's going to break down. And so you can see is basically the exact reverse direction of a synthesis reaction, where you take AB and you decompose it, you break it down to form A and B. Again, A and B may be compounds, but they will be less complex compared to AB. Where, again, you have one complex thing breaking down into two simpler things. The final type of reaction here that we've got is a combustion reaction. Now, in a synthesis and a decomposition reaction, I see A and B as being very vague and not specific at all. In a combustion reaction, it is extremely specific because you can't have any random element. It must be carbon, and it must be hydrogen, and it must combine with oxygen gas, O2, and it will always form carbon dioxide gas and water vapor. So it's extremely strict, and the only thing that you'll see vary in a combustion reaction is the subscripts for your hydrocarbon, the subscript for your C and the subscript for your H, telling you how many carbons and how many hydrogens. Now, what we're going to do is we're going to take a little bit closer look at those combustion reactions, just to get a little bit more specific on this formula where CnH2n plus 2. Well, let's predict the formula when n equals 1 for this hydrocarbon. So if n equals 1, there should be 1 carbon. So it should be C1. And then if n equals 1, all right, if n equals 1, then your hydrogens, 1 times 2, should be 2, plus 2. So it would be 1 times 2 plus 2, which would equal 4. So it would be C1H4, which we know we can write truly as CH4. And this would be also known as methane. All right, methane. Many burners contain methane. You might have methane gas in your home to heat your home or to cook your food with. You either have methane or propane. We'll get to that here in a second. Next up, when n equals 2, what would be the formula? Well, if n equals 2, then there's going to be 2 carbons, so it would be C2, and we'd have 2 times 2 plus 2 hydrogens, or 2 times 2, 4, plus 2, 6 hydrogens. So it would be C2H6, all right? And this has a name, it's called ethane. All right. It's nice to know the names of some of these hydrocarbons, just so when you hear it in class or something like that, you know what the teacher's talking about. Next, last example here, C3H2 times 3 plus 2. 2 times 3 is 6, plus 2 would be 8. So it would be C3H8. And this is your propane. very possible, very likely, that you might have a propane grill or have seen a propane grill before. All right. So these are hydrocarbons. This is where those subscripts come from. These formulas, N and 2N plus 2. All right. So now let's take a look at a few example problems where we want to identify the type of reaction for each one of these 4 reactions. Okay? Well, the first type of reaction is magnesium plus oxygen forming magnesium oxide. Okay? What type of reaction do we think this is going to be? Well, if we can recall from our little cheat sheet here, all right, synthesis reactions, A plus B yields AB. So you have 2 simple things forming a complex thing. And if we look, all right, and we compare this general form to this reaction, this is definitely a synthesis reaction. This is a synthesis reaction. Next up, we have H2O2. This would be hydrogen peroxide. You have that in a medicine cabinet, more than likely in a brown bottle. It'll break down to form, H2O and O2. And this clearly is a decomposition reaction where you have AB, you have a complex thing breaking down into 2 or more simpler substances. And those simpler substances could still be compounds. And in this case, those simpler substances are compounds, but that's okay. This is still a decomposition reaction. Next up, we have H2CO3 forming carbon dioxide, CO2, and water, H2O. Now, when we look at our cheat sheet, we can see decomposition reactions. One thing breaks down into 2 simpler things. In combustion reactions, we have something with carbon combining with oxygen to form CO2, carbon dioxide, and water. Well, in this example here, all right, if I stack them on top of each other, combustion looks very similar to this reaction, but we are missing out on that combines with oxygen. We don't have a plus O2. So that eliminates combustion from being a possibility for this reaction type. It is just simply decomposition. So we have another decomposition reaction here. And finally, when we look at this, C3H8 plus O2 yields CO2 plus H2O, our carbon dioxide and water. And I'll bring my cheat sheet here again. And now, when we see our combustion reaction stacked over top of that, you can immediately tell that this is a hydrocarbon, contains hydrogen and carbon. And if you recall, this is propane. So this is the combustion of propane. And so it is a combustion reaction, extremely strict. This is a combustion reaction. Identifying reaction types is something that's important. We have 4 examples here, 1 synthesis, 2 decomposition, and 1 combustion. These 3 are a lot less specific than this combustion reaction. And again, you know, my definition for specificity here is just A and B could be any element on the periodic table, and AB could be any compound. Whereas down here with our combustion reaction, the only thing that gets to be varied is this N, these subscripts for carbon and hydrogen. All right, that'll be all for this video. Hopefully you're able to identify these first 3 reaction types. In the next video, we'll talk about single displacement, double displacement, and acid-base reactions. All right, good luck in identifying reaction types. Thank you for watching.